Welcome everyone. So this is going to be a quick video about how to derive the electric field for a ring. Okay, so let's draw a little diagram to get started. We're going to be thinking about a ring which has a total charge of Q evenly distributed around it, and we're going to try and calculate the electric field at some point P off over here. So this I'm going to think of as the z-axis, and we'll come back to the other axes in just a moment. But the general principle for deriving this is going to be that we're going to take the ring and we're going to split it up into n equal segments. And each segment is going to have an equal amount of charge on it. So if I do that, I will say that Q divided by n is going to be delta Q. This is the amount of charge which is going to be in the individual segment. So let's think about just this little point here, for example. Okay. So now I know how much charge is just in this little point. I can figure out what the electric field is at P just due to that charge. And that I'm going to label as EI. So the I index here tells me this is this segment. This would be I plus 1. I could come up with some labeling like that if I want. And so the electric field, I'm going to write, well, we just use the usual equation. So we have 1 over 4 pi epsilon naught. And then on the top, I'm going to need the amount of charge. Well, that was delta Q, of course. And then on the bottom is going to be Ri squared. What is Ri squared? Well, Ri is the distance between the charge and the point where I'm trying to figure out what the electric field is. Well, that's just this, this line here, the distance of this line. Okay, how do I figure out what Ri is? Well, Ri is going to be equal to this distance squared plus this distance squared. So now I need to give some labels. To be consistent with the book, I'll label this to be this to be Z, and this distance, so the radius of the ring, is going to be capital R. So that means that Ri squared is equal to Z squared plus R squared. Okay, so I could plug that in right there. And so what else do I need? Well, I need to know, this delta Q I know from this term here, but there's one thing which is missing, which is that I have written down here a vector equation. So this should have a vector equation on it, and this should have an R hat. So this here would be really the electric field along a little vector pointing out of this plane. Now what you can probably see already is that if this is the z-axis, then the electric field along x and y are going to be 0 at P. And that's because there'll be a similar little vector pointing down from this point up here, and those will cancel out the y components if this is the y-axis. And similarly, the same thing will happen for x. So the only part of the field which is going to be non-zero is, of course, going to be the z component. So okay, so then I want to write down what EI along z is. So let's move over and do that just here. So EI, this is now a scalar, and I'm going to use this notation. So this tells me, make that a little bit clearer, this tells me this is the electric field due to the ith component along z. Well, what is that? It's the magnitude of the electric field there, 4 pi epsilon naught. Then I have this delta Q and also the Ri squared. This remains the same, but now I need to take just the component of it in the z direction. So to get that, I multiply by cos theta. So in particular, what this means is that if this angle is very small, i.e. if this radius goes to 0, then this term is going to go to 1, and all of the electric field is along the z component. If you are a little bit confused about this, then ask a post on Moodle, of course, to try and clarify. I hope I've said enough there to make it clear. Okay, so what have I got? I've got this cos theta here. Well, I'd like to get rid of that because I can figure it out from all of the other lengths that I have in the problem. So what is cos theta going to be? So cos theta is going to be equal to z divided by Ri. So that's just this distance here divided by this distance here. Well, of course, we already know what Ri is, so we can write this in as z is going to be equal to 1 over z over So it's z squared plus r squared. Taking that from this equation here and taking the square root, of course. Okay, so now I can plug that in up here. So therefore, EI along z is equal to delta Q. I'm going to pick up a z from here. And then I have 1 over 4 pi epsilon naught. I have the Ri squared here. Well, Ri squared, as we said, was z squared plus r squared. And then I'm going to multiply that by this square root right here. And so that's going to give me a factor of 3/2. Z squared plus r squared all to the power of 3/2. Okay, so what have I done so far? I've managed to figure out what the electric field is due to the ith segment at P in the z direction. But what do I want? Well, of course, I want the electric field from all of those n segments. How do I calculate that? Well, I can write it out here. The electric field in general along z is just the summation from I equals 1 to n of all of these things that we've already calculated. Pen is slightly running out. Okay, well, this term is just given here. Now we notice something. What we can see is that the z's and the r's are all constant, and the epsilon naught, of course, is all a constant here and is not going to enter into this equation. So I can take those through the summation, and I'll end up with a delta Q z divided by 4 pi epsilon naught, and then this term, this z squared plus r squared all to the 3/2. And then I just have that summation, I equals 1 to n. And so now I've taken everything through. I need just a 1 here just to say that I have to sum something. So if this is just a constant factor, I could also have left the delta Q over there. That's what's done in the book. But you'll notice that if I sum 1 from 1 to n, that's just going to give me n. So that's nice and easy. I'm going to save myself some time and just rub that out and replace that with an n. Excellent. And now what do I have? Well, I have a delta Q here and an n. And we'll remember from our definition that delta Q times n is going to be equal to Q. So finally, I can write that the electric field for the ring of particles is going to be Q, so the total charge, times z, the distance that point P is away from the center. Here we just have our constants, and then we have this term which tells us, this r squared term here tells us the radius of the ring of particles. There you have it. Thank you very much.